Welcome everybody. Thank you for all your questions for this second round to give answers and in the role of Ask the Professor. We are standing here in Holland at the central area to do the traffic control. We will see here many central organizations who can do the traffic control. We have some of them, and here in Utrecht that's the biggest one, and also where I'm standing in front of the building. Let's talk about the questions. The question number one. We saw dispatching on local, regional and national level. Is there also dispatching on international level? And the second one, in Europe we have several international trains with several boarding crossings, both for passengers as for freight trains. Do countries communicate with each other on these trains? And the answer is yes, of course. When you look at airplanes, you have also towers who can control the traffic on the air, and we have the same procedure on traffic with the rails. So in Holland we have the districts with several contract areas who they can control the trains and running all on the rail. So when a train is going national, it's no problem. We can control it as an infra manager itself. When they go across the border, then there must be communication in between how they control this train safely to the border or over the border, and then there is also a connection with the other control center like we are standing here in Utrecht. So that's the way how it works. The procedures is different per country. And why? Because safety is always the number one, and we talk about safety, we talk about signaling and control of the trains. And this is really important, that you have the right language per train when they go across the border. Now I'd like to give and handle question number two. You have several questions about performance parameters of trains, trams or other things in the railways. And I think it's a good question, because you like to know what is really the performance of the train and the infra. But that's not easy, because when you like these answers in your email box, it's not open, it's not public. And it is because it is sensitive between the contractors and the infra managers and rolling stock also. So in between there are contracts, and it is really sensitive to put that just online. It's not because it is a secret, we cannot say, you may not see it, but it is more because of the contracts and the sensitivity in between and how to control this. So the parameters are there, yes. And sometimes when you look at the public website of ProRail, you can also see key performance indicators on the website itself. So you can also check, for example, how good is what about how robust is the system, what about the possession time, and etc. etc. So there is some information available on the website. So please check on your website in your own country if there is some performance indicators ready on the website. If not, maybe you can find it on Google or whatever, but it is sensitive, and that's why they are not so open. When you look at the airspace and aircraft industry, you also see that not everything is there. For example, when we have a problem with rolling contact fatigue, you don't see these messages just in the newspapers. And why? Because it is not an incident, it's not an accident. It happens, and we don't. I think the industry doesn't like to say everything what's ongoing, and it's also not necessary, because the safety is not a question. So why should we bring that to the world? Everything. The same with the aircraft. Some aircraft are not going in the air because there is a problem, safety or cracks or whatever. And that's the same story here in railway systems. Now I'd like to go for an answer for the next question, and the next question is about ERTMS. So thank you for that. But first I'd like to give more in-depth about ERTMS, because what is it and what about the history of this? In the old days you can see that we have the old signs and signals like here. The problem here was it was mechanically, and everything what moves can be broken or will not function. So it was also a heavy assets, and you have a heavy control this, like these ropes you had or chains to control it. And this old ways, or you don't see anymore in Europe, maybe in other countries, but in the next time we see this all this happening in changing this electrical, and we see these signals as you see it as now in track, and that's what you see with LED signalings and the new way of signaling. To control this is that we have to get rid of this, so we don't have these expensive assets in the track. And that means that we ERTMS, the E from European, means that we have a European controlling system, that we can use this in the track But better is not use it in track because it is cost efficient, not that high. So why not use this in the train? So then you get a higher level of ERTMS. So what we have now is ERTMS level 1, you could say. That's just as it is outside with the normal signals you can see outside. And the next phase is, okay, can we put that in the train? So we have signaling systems in the train, so that is not necessary anymore that we have no assets of signaling in the track. What I like to tell now is, okay, what was the question about ERTMS? ERTMS works with a fixed braking distance for a particular train combination. Yes, that's true. It's not aware of the real surface issues, so the surface is not defined. So it presumes it will be using the most pessimistic parameters, and the system will oblige the driver to drive as if the rail is always slippery. I think that's the right conclusion. This will limit throughput over a line. And I fully agree. So when you use ERTMS, as I said, you have ERTMS already on board of the train. You like also to use the capacity of these onboard systems, because then you can also have a closer contact with another train. So you obtain more space in track. And also when your braking distance is not based on slippery track, but just as it is, you can also have a better distance and also a shorter breakage distance. And therefore you need friction modifiers, and you have to control the slippery track. And that's another challenge you can do by research, but also control this by slippery sensors inside the train. Nice to see is what we see here is the black building over there. The black building, you can see that this is a power unit to supply the energy to the trains on the catenary and for the trains for the pantographs. So this system is used as a battery, you could say, a transformer of energy who can put the high electricity on the power line. So when you see here, this building over here gives a space, and there's also a safety issue, because when there is a disturbance or there is a circuit ongoing, then you have to be safe. So the fire brigade is inside the building too, to have safe issues. You can also see the piles on top. That's because of the thunderstorms. So when the thunderstorm is going inside this building, it will not go inside, it will go guided outside and then put it in the ground. So we have no problems in this power station also. Another question that asked the professor, I like to show you the control room. You can see over here, and that's when there are really accidents or disturbances on track. So not for the traffic controllers, that's what we discussed in another question. But here you can see the nerve center, you could say, of Holland in Utrecht city, that we can control all kinds of problems and disturbances outside. What you see here is when people are working here quiet at the moment. That's because there are no incidents or accidents or whatever. So people are really quiet, and that's the good attitude, of course. But when there are really problems, for example, a derailment of a train, then people have to act. And therefore we have this big room where all the stakeholders in operations are available here. For example, the maintenance contractors are there, the rolling stock owners, all kinds of freight operators are really physically inside this room. And therefore it is really easy to have connection with each other and also talk about the solution. Because when there is a breakdown of the catenary line, the power line, then the question is how long it will take and how to inform all the passengers, as you as a passenger as well, and also the freight operators. That's what is doing here back in this room. It's one big room and there is really physical contact with each other. When you look at the wall on the end, then you see all the figures, all the parameters which are really available and needed to make decisions. For example, the train operating times, the trains which are operating, they can zoom in on which traffic control room they like to have communication or whatever. Myself, I'm also in the loop for controlling when there are accidents or really big disturbances in a technical way. So sometimes also being called to come here and make the decision, for example, when there's a derailment. Not often, so I'm really glad that I'm here really as a visitor. Here in this room you can see that they use a big wide screen for all people who are working in this control and crisis room. This is the nerve center of Holland about infra management and also the infrastructures and the rolling stock owners and freight operators. They all work in this room together. But you can see they have all their own places, and one person is you could say the physical connection point of an asset owner or a stakeholder. So thank you for your questions for today. I really enjoyed to give answers. Hopefully you also enjoy this. Maybe you can also check in your own country where all this information you can take from. Maybe you can put it back to us also so we can share it on the world map. Would be interesting, I think. So thank you. Keep the mood high, and to finish the MOOC, we enjoy it very much, and I think the next 2 weeks are really interesting to follow. So please go ahead, and next time we have at the end a last movie to give answers in the situation of Ask the Professor. Thank you and good luck.